The graph of the piecewise-defined function f is shown in the figure above. The graph has a vertical tangent at line x equals -2 and horizontal tangent lines at x equals -3 and x equals -1. What are all values of x between -4 and 3, at which f is continuous but not differentiable? Key point being this, continuous but not differentiable. Well, we know that continuous lines always have an x and y value, and if they don't, then they're not continuous. For instance, here you can see a point hole discontinuity in which you lift your finger when you drag it. That's one way to tell. So like, let's say you're making a graph and you lift your finger and then keep going, you lift your pencil. That would be a discontinuity here. So you could also have infinite discontinuities where the graph goes down to -infinity and then continues at +infinity. You would have a little axis like that. Or you can just have a simple hole discontinuity. You have it like that with an empty hole in the middle. But here we can see that there is a discontinuity. That's not what this is asking. They're asking for something that's continuous but not differentiable. So now if it says anything with x equals 0, we know that's wrong because x equals 0 is actually non-continuous. Now let's look at what isn't differentiable. Well, we know to take a derivative, you literally look at that point from the point before and see if you can make a slope out of it. So here you can see that you can make a slope here. This would go down to nowhere actually, because this is not a slope because it's making a straight line down. You can make a slope out of all of this. Here you can't make a slope either because here it continues that way. However, at the very same point, it will continue this way. So we know that there's going to be a point of discontinuity there as well. We call, I think that's where it makes a V shape. That's a commonly known non-differentiable function. Because, you know, let me reiterate that again. You can continue this way. Alternatively, you could continue that way as well. So there you go. So let's see, is there any point where it's -2 and 1? Yes, C. So this isn't differential either because if you look at this, this is an undefined slope, right? There's infinite amount of y values within an x function. So here there would be, like for a graph like this is just like y equals 0. That is a real function because there is continuously one point of x and y. But here it's going straight down and that is undefined. So we know that you can't make a derivative here, nor can you make it here. So therefore, it's continuous here because you're still drawing the line, and it's continuous here because you still haven't lifted your pencil. So, therefore, C would explain this question because you have the continuous yet non-differentiable functions. I hope this made at least a little more sense to you. If you have any questions, put in the comments below, and I'll see you in the next video.